Recording, right. Here. Trisha is there, right? Making sure at least somebody there. Okay, nice, cool. Right. Yeah, season new message as well. They should be back. Yeah. Okay, nice. I see. Yeah, I see a thumbs up. Nice, good. Okay, people back. Right. So describing SYSLOG features now. So SYSLOG is the next protocol I'm going to discuss. So on to another important protocol. SYSLOG is a standard protocol used to collect logs or messages from infrastructure devices. As you can imagine, collecting logs from our devices is an extremely important part of continually monitoring the network. It is also invaluable in performing analyses when outages or issues occur. However, log messages can easily overwhelm storage devices or networks, as well as users if they are configured improperly. As such, most devices that utilize the SYSLOG protocol allow us to configure threshold levels for logging. So basically, we want some information from the devices to help us troubleshoot issues and make sure the network operating properly. But we don't want to just be flooded with information. You can't have like somebody sitting in front of a TV and watching 100 messages fly by every second. And that is very possible if you're monitoring like 1,000 devices, right? All of them could be sending information at the same time, and you could just be flooded with information, gigabytes and gigabytes of information, and you can't make sense of it because you can't process it. It's just too much. So what SYSLOG allows us to do is categorize the information, and we configure threshold levels to say, okay, we only want to know about information higher than a certain level, basically. So these are the levels. So Cisco's SYSLOG messages are categorized into 8 levels. So emergency is level 0, or the highest level, and then you have alert, critical, error, warning, notice, informational, and debugging, going straight down in level. So emergency, or level 0, is the highest, and debugging, or level 7, is the lowest. So basically, if you configure SYSLOG for level 4, it's going to send you warnings and everything higher. So think of the arrow going up here. It will send you messages that are categorized as warnings, errors, criticals, alerts, or emergencies, not anything below what you configure. So when you configure like level 2, you configure level 2 and higher. If you configure level 7, you basically gain everything. You gain level, debugging messages, plus informational, plus notice, and everything up. So as you go down and as you configure the higher levels, the numbers kind of mix up, right? But think of it as you would, I guess, is however you can remember it properly. I think of it as the lower levels. So for the lower level messages, you're only going to want to put debugging on a router when you're debugging the router, or when you have an issue that you're actively looking into. Else it's just going to flood up your database or your flash media or whatever it is you're storing messages on. Usually you'll want to configure something around here, warnings or errors, because you only want to see messages that a router considers an error, right? You don't want to see debugging information or information level information from a router to say, I just sent 2 million packets, or what else? My temperature is 28 degrees. Okay, cool. I don't need to know that. You will want to know if your router says my temperature is now 65 degrees, something seriously wrong there. Those are the kind of high level information, the higher SYSLOG level information that you want. So by default, SYSLOG uses UDP port 514. We can configure SYSLOG messages, SYSLOG message levels to filter what types of messages are sent. SYSLOG sends messages for the configured level and higher. Configuring SYSLOG levels is a balance between getting the required messages to stay informed in the network and ensuring that you don't overfill your servers and overwhelm the users or systems monitoring the messages. In addition to configuring the level, we must also configure the SYSLOG facility. These facilities are the sources of SYSLOG messages inside our Cisco device. Cisco facilities include, for example, IP, sys or operating system, and OSPF. So you see what I mean when I say sources, right? So if we have our router, but we have a bunch of different processes inside that router, right? A bunch of different parts inside the router. So we have IP, which is just general level 3 stuff, but we also have OSPF, which is a specific protocol. So if you see a message coming from OSPF, we know it is something specific to OSPF and it's not system level information. It won't be something like temperature. We expect a OSPF message to be something like neighbor adjacency lost, or MTU mismatch, as we had mentioned. So the facilities help us to identify the process in our device that is sourcing the syslog messages. Where is it? Right. So the syslog message standard, documentation for each release explains the meaning of the messages. So this is the general format of the message, right? Facility, subfacility, severity, mnemonic, and message text. So that kind of sounds like nonsense, but if you look at the message, you'll see that it actually makes sense, right? So sys, this is the facility there. Then 5 is that severity in terms of numbers. The mnemonic is just a shortened form. So config I, configured from console by somebody on VTY 0, and then you have your IP address there. So we see, we can immediately see what happened here, right? Somebody configured something on our router, which is a significant event. Somebody changed something on your router. Who configured something? Look, we have their username here. What IP address did they log in from? Look, we have that information here too. What is the gist of this message? Config I. Somebody configured something. Okay, that makes sense. What level was this message? 5. We have that 5. And which process sent this message? Sys, which was the operating system. Yeah. So you see it broken down here: the facility and subfacility, the severity, the mnemonic, and the message text. So it is just a general overview of how each message will be structured. So that's syslog. Syslog messages just look like this, and basically what we do is we configure a level appropriate to what we want on the network. We don't want to configure the level too low, like a level 7 or a level 6, because we're just going to flood our servers and we're not going to be able to store that much information. But we also don't want to configure like an emergency or level 0, because then we'll miss important information. Like this is level 5, and we might want to know who logged into our routers in certain cases. So it's very environmentally dependent. So your senior engineers will have their own standard, but now at least you understand the features that syslog offers. Right, so moving on to configuring DHCP clients and relays. Now that we understand the operation of a few protocols, let's dive into the configuration and verification of one of them, DHCP. Cisco devices can be configured as DHCP clients, servers, or relays. You can easily configure interfaces to become DHCP clients by using the command IP address DHCP. So you see config T, then int F00, and once you go into that interface, you just put IP address DHCP. Once we have configured an interface as a DHCP client, we can then run the command show IP int brief to verify if it has been configured as a DHCP client successfully and if it has obtained an IP address from a DHCP server. Right, so you see here, show IP int brief. So we don't care about this one. You see this one is method manual, so that's obviously static, right? So look at this one, pass it in at 01, IP address. Okay, so it has an IP address. Okay, yes, method DHCP. So you see, we configured that IP address DHCP command here, which is why this method showed up as DHCP here. And we also see we have an IP address on the interface. So we were successfully able to get an IP address using DHCP. Now, so far, we have been operating under the assumption that the DHCP server and clients are within the same network or broadcast domain. Because of this, the DHCP discover broadcast messages always reach the DHCP servers. So remember, we said the DHCP discover message is basically something connecting to the network and saying, hey, I want an IP address, and broadcasting that message out. That was part of the DORA process that we discovered. So for example, when your phone connects, say your home network or your home modem, your phone will say, hey, I want an IP address so I could connect to this network and connect out to the internet. And that broadcast message is limited to the broadcast domain, right? Remember, we discussed VLANs and segmenting the broadcast domain and stuff. So that discover message is a broadcast message that will go out and it will meet every device on that broadcast domain or on that network. And in many cases, you will have a DHCP server that could answer that message, that discover message. However, this is not always the case. DHCP servers may be in separate networks entirely from their prospective clients. In this case, we require a special node called the DHCP relay to forward the request from the DHCP clients to the remote DHCP server and to forward the reply messages from the DHCP server back to the client. So just imagine you have, well, it better to imagine it's in a business, right? Because this is where it's going to be in. So you have a bunch of people connected behind a modem in their homes, but you don't want to put a centralized DHCP server in each one of those modems for whatever reason. You could set up this DHCP relay to forward requests coming into that modem and requests coming from those home networks to a central DHCP server in your data center in your business. And that's what it really does. It relays DHCP requests that coming in from another network to the network that the DHCP server is a part of. So this is what it looks like here. So you have network A on this side and network B on this side. So you could have DHCP clients in the same subnet as the DHCP server, sure, on network A, no problem. But you could also have DHCP clients in another network. So like network B here, this client is in a separate network from this DHCP server. So if it sends out a DHCP broadcast message, this server on this side won't get it because the broadcast will be dropped on the router interface. So what the router has to do is it needs to act as a DHCP relay agent to relay these messages back and forth. So you see the request will come in here, then the relay agent will relay the message to the server will get it, send a message back, and the relay agent will relay that message back to here. So Cisco devices can be configured as these DHCP relays using the command IP helper address and the address of the DHCP server under an interface. This tells a router to act as a DHCP relay and forward requests to the specified server. So basically, what we're going to do is we're going to go under this interface here. So let's say it's fastnet 01, for example. We're going to go config t int fa01, and we're going to put in this command IP helper address and this address here, which will be the address of this DHCP server. And this tells the router to act as a DHCP relay and forward requests that come in on this interface here to the IP, well, to the address of this server here, which is to that DHCP server here. So you see this breakdown kind of shows the relay here. So you see R2 and look the command there. Might be a little too small to see it from your side, I'm not sure. But you can see IP helper address and the IP address here. And you should see 2303 somewhere here. Yeah, so you see 23003 on R3, which is the DHCP server here. Because we know Cisco devices can act as DHCP clients, relays, and servers. Once we have configured our DHCP relay device, we can verify that our DHCP client is able to reach our remote DHCP server using the same show IPint brief command. So we basically go on the client, which is the device that needs to get an IP address, and we put in the same command that we learned a while back, which was IP address DHCP. So you see the method as DHCP here, just as before, and we also see the IP address showing up here. So once you see an IP address show up here, you know this DHCP relay process is working. And that's the way to verify that the relay client is working. This is the command. So we went through the IP address DHCP command, and then the IP helper address command, and then did we go through? Yes, we went through DHCP server setup in one of the labs. Actually, in the wireless lab, we went through some DHCP setup. But yep, that's it. So in this class, we went over NTP, DHCP and DNS, SNMP, SYSLOG, and then DHCP clients and relays. So yeah, they pulled out DHCP servers. That's what I'm remembering. They had servers here at one point, but they only have clients and relays now. So it's just two commands to put in for that. But we did go over a server setup in one of the labs. Right. So let me know if you have any questions. Any question about any of the protocols? Also have links in there, so if you want to read up more about them, go in the links. And you should be up to lab 16. Yeah, what is lab 16? 16 is DHCP. Good. So you could set up the DHCP stuff in this lab. And then next class, we will go over QoS, so quality of service stuff, and a few of the other protocols there. Right, so if we have no other questions, you all could go ahead and try the lab and let me know if you have any issues or any questions.